This is lesson 110 on absolute value inequalities. So we just finished learning about linear inequalities. They're very similar to linear equations, the only difference being when we multiply or divide by a negative number, we have to change the direction of the inequality. For absolute value inequalities, same rule applies more or less. It's very similar to solving an absolute value equation, but we do have to take in mind that when we multiply or divide by a negative number, we have to change the direction of our inequality. Now, just like with our absolute value equations, if you recall, to solve those, we had to solve two individual equations. To solve an absolute value inequality, we have to solve two individual inequalities. So those two inequalities are going to give us two interval solutions back. Our overall solution for the original inequality, we're going to combine the two smaller solutions either by taking their intersection or their union. If we have the absolute value is less than or equal to something, we're going to take the intersection of the two individual solutions. If the absolute value is greater than or equal to something, we will take the union of those two solutions. So here's one example like what we'll see on our drill problems. So the absolute value of 8x plus 4 is greater than or equal to 3. So much like our absolute value equations, we will need to split this into two individual equations. So the first equation we need to solve, you're just going to get rid of the absolute value sign. Nothing else changes. So 8x plus 4 is greater than or equal to 3. The other inequality we need to solve, 8x plus 4 stays the same, but over here we're going to make this negative 3. When we change the sign of this, we need to change the direction of our inequality. So this single absolute value inequality, we can find the solution to by finding the solution to this inequality and this inequality. So we proceed as we would normally. Let's get our x all by itself. We'll subtract 4 from both sides and then divide by 8. So here we know that x must be greater than or equal to negative 1/8, and then a similar story here. 8x is less than negative 7, so x is going to be less than or equal to negative 7 over 8. Now if you're unsure what your solution is going to look like, what I recommend doing is drawing a number line. So here would be negative 7/8, here would be negative 1/8. So x is greater than or equal to negative 1/8, so it can equal negative 1/8, and we want it to be greater than that. So we're going to shade to the right. And then our other solution, x is less than or equal to negative 7/8, so it can equal 7/8, and it's going to be all the values less than that, so we'll shade to the left. So notice we have two different regions here, so our final answer is going to consist of two different intervals. This particular interval, there's no left bound, so we'll write open bracket negative infinity, and our right bound is negative 7/8. We are allowed to equal negative 7/8, so we'll use a closed bracket. We are going to take the union of these two regions. We will never have an intersection in our final answer. This will always be the union if we have two different regions. In this second region, our left bound is negative 1/8. We are allowed to equal negative 1/8, so we'll use a closed bracket. And then again, we aren't specified a right bound, so we're going to put infinity with an open bracket. So here is our solution to this absolute value inequality. So one more example. The absolute value of 2x plus 3 is less than 9. So to solve this, we need to solve these two individual equations. 2x plus 3 is less than 9. Again, the first one we just get rid of the absolute value signs. And the other one, 2x plus 3, we're going to change the sign of the right-hand side and change the direction of our inequality. And from here we solve each of these individually just like we would any regular linear inequality. So we're going to subtract 3 from both sides. That gives us 2x is less than 6. Divide by 2, we get x is less than 3. Similar story over here, subtract 3. 2x is greater than negative 12. divide by 2, x is greater than negative 6. So to help me see my solution, I can put these two on my number line. So here's 3, here's negative 6. So x is less than 3. I don't want to actually equal 3, so I'll put an open circle here. I'm going to shade to the left. X is greater than negative 6, so I don't want it to equal negative 6. I'll put an open circle there and shade to the right. So notice this time we only have one region. We never want to cross one of our other solution marks, so we would not have shaded past negative 6 when we're shading our solution from this inequality. So do be careful of that. So we'll have only one solution here. The left bound of this region is negative 6. We don't actually equal it, so we'll put an open bracket there. The right bound is 3. We don't actually equal it, so we'll put an open bracket there. So this is our final answer.